Hello, everyone. Some people were asking me yesterday about polynomials, and it seems like it's almost like I'm guessing when I'm drawing a polynomial, but I assure you that I'm not. So if you follow the guidelines that I set out for you yesterday about polynomials, you'll end up with the correct shape. Now, with polynomials, I'm not too concerned with the y values. I'm only concerned about the location of the zeros and the overall shape of the graph, and then it'll all come together. Trust me on this. So if I'm just going to take a look at the polynomial y is equal to negative x plus 2 squared times x minus 3 cubed. What I'm able to see from that immediately is my double zero. I have a double zero at negative 2 and a triple zero at 3. So I will make note of that here. So a double zero and a triple zero. The next thing I need to do is I always find it helpful to get the degree of the equation. The degree of the equation is 5, so it's odd. So, and my leading coefficient here is going to be negative. So overall, this function, its left-hand and right-hand side behavior, is going to be like so. So as it comes in from the left, it's going to be decreasing. As it leaves to the right, it's going to be decreasing. The next thing that I know is I'm going to put my double and triple zero in. So I know that I have a double zero at here, and I have a triple zero here. So I'm going to start this function, and I'm sorry that I don't have better graphing tools, but here we go. We're going to start the function, and I know that it comes in, hits a double zero. What happens at a double zero? Bounces up. And then once we're up here, we have to turn around, and then we're going to have to hit a triple zero, flatten out, and go through. So let me just do that right now. Here's my function. It's going to come in, and it's going to hit this double zero, and close to the double zero, it starts to flatten out. And at a double zero, it bounces up. What is my y-intercept? Actually, I don't really care too much what my y-intercept, and I'll talk a little bit about that later. But if you're curious, you can just simply take in x is equal to 0 and plug it into the function. So I'm going to continue on my function, and I know that I have a turning point not right here, but somewhere between negative 2 and 3. So where is it? It doesn't matter, just as long as it's a nice turning point somewhere above the x-axis. Make sure that it's obvious. And now I'm going to turn around and hit that triple zero where it just simply flattens out and goes down. And I always think that I'm right when I follow the left-hand side behavior, then follow the behavior of the zeros and their different types, and my right-hand side behavior matches up with what I expected. So there's my polynomial function. Unfortunately, with this graphing software, I'm unable to eliminate the y values. Otherwise, I would have. So that's it. Maybe, I think it might be a useful exercise here. Well, what does the function really look like? Well, the function really looks like this. We have a, whoa, this is kind of crazy. It actually looks like two functions, but it's not. What happens with polynomial functions is the y values get so large and so small that actually the behavior around the zeros is lost. And the behavior is really important. So how do I know where a turning point is? Calculus. How do I know where my y values are? I simply take an x value and plug it in if I'm interested. My goal isn't to make a really accurate graph here for you in grade 11. In grade 11, we just want to get the behaviors of the graph. Anyways, I'm just going to zoom out on my graph and see where we're at. This is what this function looks like. And oh, this is a nasty little thing, isn't it? It looks like it comes down, hits that double zero, bounces up, goes all the way up to, has a y-intercept of 108, as I said, then goes all the way up to this max I have no idea, then comes back down and hits that triple zero. So as you could see, there is nothing nice about the real polynomials. And the polynomial graphs, you might be getting nonsense when you plug it into the equation for an x value. You might get an output of negative 240, but that might just be right. It's just that the y values are so extreme with a polynomial. I hope this video has helped clean up some questions, and maybe it raises more questions.